So, what's your name?
My name's Ethan.
And what do you have to show us today?
Well, today I have to show you about 2 pages of code. And then it makes this, which is planets orbiting a sun. And the sun is basically following the mouse, and the planets are following the sun, or the mouse. And if you click, then it basically respawns everything so that you can have new planets with new colors and new sizes. And I even made it so that occasionally, about a 1 in 20 chance, so this could take a while.
You're wasting up all the video time, Ethan.
No, I'm not. That's just your imagination.
That's not quite a 1 in 20 chance.
Yeah, it is. Shush. It'll happen. There we go. So I made it that sometimes a surprise square planet will appear who's not supposed to be there.
Okay, so how exactly did you do all this?
Well, it all starts with things called p-vectors. And what p-vectors basically are is a convenient way to make an x and y location together. So that way you can define a point in space using one value. So, in the setup, I have this thing.
Extreme.
This thing right here would be introducing something called an array.
This cannot zoom in quick enough.
Okay, so
or detailed enough.
This is an array, and what an array is basically this repeating an object with the same thing except it's a different type of object. So if you look here, this is a class, and I'll explain what they are later, but a class is basically a cookie cutter for an object. So this is basically cutting about 5 cookies or planets. So right here would be setting up the window, setting up the object, and this is setting it up so that it's a random color every time and also a random size. And
well, it's not completely random, isn't it?
Well, it's completely random within a range of 255. And also the size is random within a range of 25 to 100. So right here would be setting the background and making sure that the animation flows smoothly so it doesn't leave a trail. So if I actually took that out, and this is a comment, so it basically takes it out, what happens is that it leaves a giant trail and there's no background really. So this is necessary to make a sort of animation. And here would be setting an ellipse, which is the sun, which is following the mouse. And this would be at position mouse X, mouse Y. And this would be basically setting all of the arrays of planets to the function move. And the function move is where we get into p-vectors. And p-vectors would be, this one for example is a p-vector. And what it does is it takes position of the mouse and assigns it to this. So the new p-vector m is position of the mouse. And this vector would be the subtraction of mouse to location. So if you know any vector addition or subtraction, you should be able to know that a vector minus a vector produces the vector required to get to that point. So right here would be location and mouse. If you subtract those, you get a value which basically tells it to go which direction. After that, I normalize it in order to make sure it doesn't go out of control, and then I multiply it by 0.75 in order to scale it down a little bit. And then I set it equal to the acceleration, and after that, I add the acceleration to the velocity right here. So since acceleration is changing velocity and velocity is changing location, I can basically say that velocity plus acceleration, and then after that, I limit the velocity, and then I go to location plus velocity. And I want this created sort of effect where it orbits the mouse, like so. So the last thing I want to explain is how I did the random thing. So what I did is I made a variable called surprise, and I basically said that surprise is assigned a random value, which is one of 50 numbers. So it goes from 0 to 50.
So it's a 1 in 50, not a 1 in 20 chance.
Shush! I changed it last minute. I forgot. And
Just
also, it's a
double
1 in 51 chance because 0 is counted as one of them.
True that.
So what I did here is, if surprise is less than 1, which means if it's 0, then it activates a surprise mode, which basically tells it to draw the surprise square. And otherwise, it just draws an ellipse, which is basically what the plan is to solve. So that is all. And is there anything else that I should explain, Michael?
I think you've already explained way too much.
Oh well. So bye, if you're still there.